The third topic is about induction and deduction, which are the basic forms of scientific inferences. If you have data like this, you may ask question: do you observe any pattern in your data? And you would probably answer, yes, I see something like T and I see something like X, perhaps. So this would be your answer, and the process how you get the knowledge about T and X is induction. So from new data, from data you got in your research, you inductively generated information about T and X, while deduction works differently. You have your data, and the question is, do you observe L pattern? Do you see L in your data? And your answer can be yes or not. So I would say yes, I see L, but for somebody it's not so evident, especially if we make it bigger, if you look for if we zoom in. So we would say probably we don't see L, or if we make it like this, so we don't see L. So it's not obvious that we see L in it, but if we say yes, either yes or no, it's deduction, because we have something abstract at the beginning, and we look at data, and we answer if it is present or not. So to explain it, induction moves from the particular to general, from a set of specific observations to the discovery of a pattern that represents some degree of order among all given events. This is definition, and I have illustration. We start with set of specific observations, and we see like interrupt two groups of axes, and we observe more in data, and we find the line of axis. So yes, line of axis, this is the pattern. But we do more observations, and we found another group of axes, and finally, after long observation of our data, we discover this shape, T shape, and we say, no, it's not a group of axes, it's T. This is the result of our observation, and we discovered a pattern. The pattern is T. So this is the process of induction, that we started with observing axis, and we ended with the pattern T. Deduction or deductive reasoning moves from general to specific, from general or abstract. It moves from a pattern that might be logically or theoretically expected to observation that test whether the expected pattern actually occurs. So this is the expected pattern, T, or abstract. It's abstract. It's abstract in the sense that T, we can, if I say draw T, you can imagine it and draw it. So you don't need to look at particular T to be able to draw T. So it's something abstract. You can have an abstract memory of it. So there is a shape T, and we test if this group of axes is an occurrence of the shape T, and we can say yes, probably, but this I would not say it has shape T. So this is I can say the T does not occur in this data. So this is deduction. We have some abstract idea or some abstract pattern, and we test if in our data we can identify it. In reality, it's more complicated, as usual. This is an example of poem. It's not social science, it's poetry, but I think it's a nice example. If we analyze it, we must approach it, or automatically we approach it with some deductive elements, because we know it's a poetry, so it's a poem, and we know poem is an abstract idea. What is poem? So we look for poetic elements in it, but we don't know exactly what kind of poetic elements are in this poem. So this is induction, that we must like search for any pattern, and we must think, are these patterns, or do these patterns contribute to abstract idea of poem or poetry? So we must combine elements of deduction. So at the beginning we have an idea of poem, but also this induction, that we must search for patterns that are not entirely known to us. We don't know all possible patterns of poetry. It's open, so we don't have any like fixed set of patterns that can occur in poetry, because there is a shape which makes the poetry. And if I ask before this, is the shape of letters something that is poetic? Most of you, including me, would say no, shape of letters or shape of lines is not a part of poetry. But we can say that yes, it is, it can be. So in social sciences, we must use both to describe a phenomenon. We must use both deduction and induction. For example, here, in an inductive way, we cannot describe all patterns. There are patterns regarding that it's like encounter of many persons, many individuals. There are men and women. There are numbers. There are police. There are some letters or poster. So they have different type of hairs. So that what is important pattern, relevant pattern or not? We cannot do just induction. If we start with pure induction, we will finish with a long book of description without any difference between importance of these descriptions, between importance of patterns. Is the pattern, if the gender composition pattern, more important than age composition pattern? So we don't know. From induction we cannot say what is more important or not. So we need some theory at the beginning which says what should be more important than what should be more important in the protest movement. For example, the gender composition can be very important, or age composition. It depends on the theory, what we want to discover. But if we start this pure deduction, we will finish nowhere, because if the question is this event organized or not, we cannot answer it like clearly. It's partially organized and partially not. So we must look for details of organization. We must start to be a bit inductive to be better deductive. So what I try to say is that in science and in social science as well, we do both. We do observations, we generalize these observations by induction to get theories, and from theories we use deduction, we create a hypothesis that we confirm or verify or reject or modify by observation. So we do, to have to produce new knowledge, we need both induction and deduction. And questions for you: try to write in 1 or 2 sentences, how would you approach pandemic as a phenomenon, current pandemic, inductively? What would you do if you study pandemic inductively? And the same thing with deduction. So how would you study, how would you approach pandemic deductively? Just 1 or 2 sentences.